Hi, my name is Mr. Samuel Oketch. I'm a teacher of physics and mathematics. And for today's class, I'll take you through physics. And for today, I'll teach you force. So let's look at force. Now, force is a push or a pull on a body. It is a push or a pull on anybody. Like, for instance, we may have a ball. We may have a ball on the ground. Then, if someone kicks it by applying a force on it, then this ball, three things are possible to happen. One, it will, if it was stationary as it is, it will start moving. And it will move in the direction in which the force is given. Secondly, its shape can change. So, the force applied on the ball has an effect of causing it to move or changing its shape. And thirdly, if any of the two doesn't happen, then the third one is that its size will be affected. So force is a quantity which, when applied on an object, can cause the object to move, changes its shape, or its size. And so it can be described, in other words, a force can be described as a quantity. As a quantity that changes the motion of an object, or the shape of an object, or the size of that particular object on which the force is applied. And diagrammatically, a force, when represented on a drawing, has a magnitude. The magnitude of the force is the size of that particular force. How big or how small that force is. And also, a force has direction. So these are the two main properties of a force, that it is a quantity that has magnitude and direction. In other words, we can say that a force is a vector quantity. In the previous class, we looked at the various types of quantities, and we said that in physics, physical quantities can be basically divided into two. We have what we call vector quantities, and two, we have what we call scalar quantity. So just as a reminder, what does a vector quantity refer to? Now, a vector quantity is a physical quantity that has got both size and direction. Is a physical quantity that has got both size and direction. An example of such a quantity, example of a vector quantity include force, the one we are looking at today, and the other one is pressure. We also have weight, etc. When describing a vector quantity, we must talk about the size or the magnitude of that particular vector quantity, how big it is, how small it is, we must also describe the direction in which that quantity is acting. Is it acting horizontally, upwards, downwards, or sideways? Like, for example, a force of, say, 3 newtons must act in a particular direction, whether eastwards, westwards, southwards, or northwards. Another one is pressure. Pressure must act in a given direction, and so therefore, when we're describing the pressure, we must ensure that we give the size of that pressure and the direction in which that pressure is acting. The other classification of physical quantity that we discussed was scalar quantity. And scalar quantities are defined as physical quantities that have got magnitude only. Magnitude or size only. So, scalar quantities do not have direction as opposed to vector quantities, which have got both magnitude and direction. Examples of scalar quantities. Examples of scalar quantities include: 1, we have density. The density of an object only describes about the magnitude of that quantity, but not the direction. The other one is volume. Another one is temperature, among many others. And so, back to where we were, we describe force as a vector quantity. Therefore, in terms of representation, we must represent the force in terms of the size and also in terms of the direction. For example, a force of 3 newtons, a force of 3 newtons acting downwards will be represented as with an arrow. The arrow tells us the direction in which the force is acting. And then the unit 3 Newton is the magnitude of that particular force. So generally, a force is represented in form of a diagram as with an arrow. It is represented with an arrow. So the arrow, the tip of the arrow, shows us to which direction the force is acting. Then the other bit that you need to understand under the introductory part of force is the unit. The unit of force. Now, the SI unit of force is the Newton. The SI unit of force is the Newton, abbreviated as capital N. For example, 3 newtons, where a Newton here is the unit of measuring force. Although it can be converted, there are other multiples and sub-multiples of Newton. For example, we have the kilonewton. So therefore, you can convert from the Newton into kilonewton using the appropriate conversion factor. Now, the acceleration of 1 gram on the Earth's surface, the acceleration 1 gram is equivalent to 10 Newton per kilogram. So the gravitational pull on the Earth's surface is 10 newtons per kilogram, meaning that a body whose mass is 1 kilogram has a force or a weight of 10 newtons acting on it. Now, having looked at that introduction, we need to look at the types of forces. So let's look at types of forces. Types of forces. There are various types of forces, and all these types of forces can either be contact or non-contact. All the various types of forces can either be contact or non-contact, whereby contact forces, what are contact forces? Contact forces are those forces which can only occur between or among bodies that are in contact with each other, as we shall see. For example, an example of a contact force is friction. Friction force can only be experienced when two bodies are in contact with each other, whereas non-contact forces are those forces which can be experienced even if the two bodies are not in contact with each other. An example is magnetic force. When two magnets are brought together or closer, not necessarily touching each other, then the force of magnetism will be experienced, even if they are not in contact with each other. The other one is electrostatic force, and many others that we shall see. So therefore, what are the types of forces? Now, the first one the first type of force is referred to as the gravitational force as our first one. Then the second one is the frictional force or the force of friction. Then the third one is magnetic force. Then the other one is electrostatic force. The fifth one is elastic force. Then our sixth one, number 6, is upthrust force. We also have cohesive force. And the eighth one, we have adhesive force. So then the ninth one is surface tension. is referred to as surface tension. And so we have a number of forces as we have listed. The first one is gravitational force. Second is frictional force, or the force of friction. The third one is magnetic force. The fourth is electrostatic force. Number 5, elastic force. And 6, upthrust force. 7, cohesive force, or the force of cohesion. Then 8 is adhesive force, or the force of adhesion. Then the 9th is surface tension. Then the 10th one is centripetal. Centripetal force. So let's look at each of the forces one after the other, beginning with the gravitational force. Let's look at gravitational force, also referred to as the force of gravity. So the gravitational force refers to the force of attraction. This is the force of attraction between two bodies. This is the force of attraction between two bodies that have got masses. Between two bodies that have masses. In other words, first, there must be two bodies, at least two bodies. And secondly, the bodies must have masses. For instance, if a body M1 and another body M2 are separated by a distance r, then the body M1 and the body M2, these two bodies experience some attraction between them, whereby this force of attraction that exists between M1 and M2 is what we are referring to as the gravitational force. It only occurs if these two bodies have masses. If they are massless, then there is no force of attraction between these two bodies. And again, it is the gravitational force that causes attraction or pulls objects that are near the Earth towards the center. We find that those objects which are, whenever you throw an object, for example, in that like that, it always falls towards the center of the Earth. This is because there is attraction between the object that you have thrown up and the Earth. The Earth is a body which has got a mass, and the object you have thrown up is also a body which has got mass. So there is always that pull that attracts objects thrown from the center of the Earth upwards to fall towards its center. So that force which causes that attraction is the gravitational force. And from our earlier classification, we classified forces as either contact or non-contact. Therefore, we can simply say that gravitational force is a non-contact force, because the body, for example, the body you have thrown up will fall, although it is not in contact with the Earth. Another one is the moon, as an example. The moon experiences a gravitational pull of attraction towards the Earth. As the moon orbits the earth, if that's the earth, then the moon is orbiting the earth. The moon has got some mass, although very, very much lower than that of the earth. So the earth also have got a mass. So if this is the moon and this being the earth, then there is the force of attraction which tries to bring these two masses, that is the earth and the moon, together. Moving on is the second type of force, which is referred to as the frictional force. So let's look at the frictional force, or the force of friction. So, what is friction force? Friction force is a force that opposes relative motion between two surfaces. So it's a force that opposes motion between two surfaces. For instance, if someone is walking, then you realize that the sole of his or her shoes, there is that surface and the ground. There is a contact between the shoes and the ground. So the ground tends to oppose the movement by this person. Or the other one is the riding. The wheels of a car normally experiences some kind of opposition from the road. So this kind of force, which tends to oppose movement, relative movement between two surfaces, is what we refer to as the force of friction. And friction force is a contact force. Friction force is a contact force. This means that it cannot occur when two or more bodies are not in contact. Therefore, it only affects two surfaces that are in contact with each other. No matter the direction of movement of a body, frictional force will always occur in the opposite direction. For example, if this is the surface of the rod, then we have a car moving on the road, then in that particular direction, then there is friction force between the tires and the surface, such that if the car is moving in that direction, then frictional force will occur in the opposite direction. So this is the frictional force, but this is the direction of movement. Now, something that you also need to know about friction force is that it has got merits and demerits. The merits of friction. It has got a number of advantages. For example, one, it enables us to write. It enables one to write. Without friction, we will not be able to write using your pen. The surface on which you are writing and the tip of the pen, there must be a friction that occurs between those two surfaces. If there is none, then you will not be able to write. Then two, even walking. Frictional force enables someone to walk. So we can move from one place to another because of friction. But apart from its advantages, it has got some disadvantages. So demerits. of friction. The most important disadvantage of friction is that it causes wear and tear. It causes wear and tear of the moving parts that are involved during frictional force. For example, the wheels of a car get worn or day by day or time by time as the car keeps on moving on the surface. So they are being worn out. They are getting torn. So even, for example, ball bearings, these parts also get worn out. So you need to do the oiling from time to time, or you grease them so that they are prevented from being worn or being torn. That is caused as a result of friction. Then the third type of force is elastic. Now, elastic force is defined as a restoring force that exists when an elastic material is stretched or compressed. So it is a restoring force that exists when an elastic material is stretched or compressed. An elastic material is that material which, when it is compressed by application of a force or stretched by applying a force, then it tries to retain its original shape and size. And so, the force which enables this elastic material to restore its original size and shape is what is referred to as an elastic force. Therefore, elastic force occurs in elastic materials. And an example of elastic material include examples of elastic material include a rubber band, or the other example is a sponge. So, when you compress a rubber band or when you stretch a rubber band, its size and shape will be changed. It will be altered. And therefore, when that particular force is released, then the material, the elastic material, if it is still within its elastic limits, then that particular material will gain its original shape and size as it was before the stretching or before the compression. But remember that when the elastic material or elastic limit, is exceeded, then the elastic material will not be able to restore its original shape and size as it was before the force was applied. Therefore, that is how elastic force occurs. It is a contact force, as we are the other type of force we are seeing, that only exists in elastic materials. Then the other type of force is magnetic force. So let's look at magnetic force. Now, magnetic force is a force of attraction or repulsion that occurs between two magnets. Is a force of attraction or repulsion due to a magnet. So if two bodies are either being attracted or being moved or repelled due to a magnet, then that force which occurs between those two bodies is a magnetic force. For example, if we have a bar magnet, there is some region within this bar magnet that the force of attraction or repulsion due to this magnet can be experienced. So on the bar magnet, one pole is a north pole, then the other one is a south pole. So on this region, within the region that is shown by the dotted line, the magnetic force of either attraction or repulsion due to this bar magnet will be felt. If it happens that another bar magnet or a magnetic material is brought closer, or it can be within this boundary, then attraction or repulsion will occur. So therefore, if what happens now, if we have two bar magnets, if we have two bar magnets which are brought closer to each other but not touching, one side that's a north pole, the other one is a south pole, then this other side is a south pole, the other one is a north pole. Then we expect that these two bar magnets will be repelled from each other. In other words, there will be no attraction. Why? Because this side is a south pole, while the other bar magnet, this extreme end is also a south pole. Therefore, a south pole and a south pole will repel. There will be repulsion. But what happens now when we change the polarity of one of the bar magnets such that we have a north pole and a south pole, while for the other second one we change the polarity so that it becomes a north pole and a south pole. Then what will happen here is that there will be attraction. The first one will be attracted towards the second one as well as the second one. So in this second diagram, attraction occurs. Why? Because the south pole and the north pole are unlike. So attraction occurs. In other words, a south pole and a south pole, or a north pole and a north pole, experiences repulsion, while a south pole and a north pole experiences attraction. In summary, what you can say is that like poles repel, while unlike poles attract. So, any two like poles will repel each other, while any two unlike poles will attract. And that is shown by the sketch as we have on the wall. Now, this force of attraction or repulsion due to a magnet is what we refer to as magnetic force. So, the attraction or repulsive force of two magnets is strongest also at the poles. So at the north pole or the south pole end, this force of attraction or repulsion is very, very strong. But in between the repulsive or the attraction due to the bar magnet is not as strong as it is at the ends. That is also some point to note in that case. And so that is how magnetic force occurs, or the way it is felt. Then let's look at the other type of force, and that is upthrust force. So we discuss upthrust force. Upthrust force. An upthrust force is an upward force that acts on an object which is placed in a fluid. So it is an upward force acting on an object that is in a fluid. So what is a fluid? A fluid can either be a liquid or it can be a gas. And therefore, an upthrust force will not be experienced in a body that is not in a fluid. If a body is in, for example, in a vacuum, where there is no air, nor any other material, then there is no upthrust force. So, for example, if a stone is thrown in a pond, as the stone goes down, it experiences some opposition. As it goes towards the depth of the pond, there is an opposition. And therefore, we can represent the forces that are acting on our stone as shown here. The weight of the stone is acting downwards. So this is the weight. But the upthrust will act upwards. So this is upthrust force. Such that this stone or this body will move downwards due to the net effect of the two forces. Therefore, the resultant force, the difference between the upthrust force and the weight of the object, will result in the object moving downwards. Therefore, again, this upthrust force can also occur in an object that is floating or on a fluid. So if an object is floating in a liquid, then it is floating, it's not moving downwards, it's not sinking, in other words, then that object also experiences an upthrust force, meaning that the net effect of the upthrust and the weight is zero. And so, therefore, the object is neither thrown upwards in the air nor sinking downwards into the liquid. And so it remains floating on the surface. Then the other type of force is cohesive and adhesive forces. So let's look at cohesive and adhesive forces. Cohesive and adhesive forces. We begin with cohesive force, or the force of cohesion. Now, cohesive force is the force of attraction between molecules of the same kind. This is attraction between molecules of same kind. For example, we may have water molecules attracting other water molecules. So water molecules and another water molecules. Those molecules are of the same type. They are of the same substance, and therefore the force of attraction that occurs between them is the cohesive force. If we have mercury molecules attracting other mercury molecules, then In that case, we also have cohesive force because mercury molecules and other mercury molecules are molecules of the same kind. But if they are of different kind, then that is another type of force that is altogether, and that leads us to adhesive force. And adhesive force is defined as the force of attraction between molecules of different substances. So this is another force that involves attraction between molecules. But this time around, they are molecules of different substances. Molecules of different substances. For example, the attraction force between a glass surface and water molecules when they come into contact is due to adhesive. So that when water molecules or when water is poured in a glass, then you realize that there are droplets of water molecules that remain on the sides of the glass or at the bottom of the glass. That is as a result of attraction between those water molecules and the glass surface. So a glass is of a different substance, water is also of a different substance. So this type of force is what we are referring to as adhesive force. Now, if adhesive force is experienced between water molecules or between molecules of different substances, then you realize that those molecules or droplets of water molecules that remain on the surface or on the sides of the glass is occurring because we realize that there is a stronger force of attraction between water molecules and the glass surface, which is much stronger than that attraction between molecules of water themselves. Like in this case. So, if we can represent that in a diagram, so that this is our glass, then when we bring in water, when you fill this with water, then finally you empty the water, you empty the glass so that the glass remains empty. Then you realize that still there are some molecules which are attached on the surface of the glass. So you realize that there is some attraction. If these are water molecules, so these are water molecules, and this is a glass. When that attraction is much stronger than the water molecules themselves, so instead of all the water molecules going out of the glass, some remain. Why? Because they are strongly attracted to the glass as opposed to them being attracted to each other. So that which makes the surface of the glass wet is because of the adhesive force. While if we consider mercury molecules, they behave differently as opposed to water molecules. Mercury molecules are strongly attracted to other mercury molecules than mercury molecules being attracted to the glass surface. So therefore, the attraction between mercury molecules, here mercury molecule, plus another mercury molecule, in this case, we are experiencing cohesive force. So here we have cohesive force, which is much stronger than adhesive force. There is adhesive force, yes, but the magnitude of the cohesive force and that of adhesive force is less than the cohesive force. And so, what are we saying? Now, what we're saying is that a mercury molecule attracted to another mercury molecule in this kind of attraction, there is cohesive force. But if we have mercury molecule attracted to a glass surface, then here there is adhesive force. And that in the first scenario, the cohesive force is stronger than the adhesive force. So the mercury molecules will remain as spherical molecules. They will not wet the sides of the glass, as opposed to water molecules which will wet the sides of the glass. Now, having discussed the various types of forces, let us now discuss the effects of forces. What is the effect of a force on a body? Okay, effects of forces. From the beginning, I say that a force is a push or a pull on a body. And therefore, when you kick a ball, for example, then this ball, as I said, three things are likely to happen. We are going to cause some movement. It may have an effect on the movement, or it can have an effect on its size or the shape of that ball. And so, broadly, the following are the effects of a force on an object. Number one, it can cause a stationary object. It can cause a stationary object to move. If a stationary ball, for instance, is kicked, then it will start rolling or it will move. Another effect or another example is, for example, when you push a carton. If a carton is stationary, then you push it or you pull it, then it starts moving. Then the second effect of a force is that it can cause a moving object to stop. So it stops a moving object. For instance, if two vehicles moving in opposite directions collide, the first vehicle is of F1, the second vehicle is of a force F2. If the magnitude of this force and the magnitude of the second force are equal, then the two forces will neutralize, will cancel each other, and therefore the two vehicles which were moving remain stationary. So that is the second effect. Then the third effect is that it can change the direction of a moving object, can change the direction. of a moving object. Still using an example of a car. If a car moving on a straight road hits an object on its path, then if the car does not stop moving but remains in motion, there is a possibility that it will change its direction of movement. So it no longer moves in a straight line, but it can move in that manner. And therefore, an effect of a force on an object is that it can change the direction in which the object is moving. Apart from that, it can cause an acceleration or a deceleration. So, the fourth effect is that can cause acceleration or deceleration of a moving object. In this case, an object is already in motion. When an opposing force is applied, then it will cause a deceleration. In other words, it will reduce the speed at which that object was moving. But if the force is applied in the same direction as that of the moving object, then it will cause acceleration. It will cause that object to accelerate. And so, what happens? That means that its speed will increase. So if you have an object, then you apply a force, a moving object, then you apply a force in the same direction as to the object, then the speed of that object will increase. Then another effect is that it can distort the shape of the object. Distorting the shape of the object to mean that the original shape of that object before the force was applied will not be the same as the shape it will have when the force has been applied. And so we realize that by stretching or compressing an elastic material, for example, we end up affecting the shape or even the size, the shape and the size as well, the shape and the size of the object. Then lastly, a force can cause a turning effect. It can cause a turning effect. So, a turning effect will result from the moment of the force. A turning effect will result from the moment of the force. So, what is this moment? Moment refers to the product of the force and the perpendicular distance from the pivot. And this takes us now to the calculation of forces. And so, in our next session, we shall discuss about the calculation of forces. Otherwise, thank you for listening. Nice day.